Thank you very much. Are there any questions? We have time for 2, maybe 3 questions. Yes.
So you say that the advantage is that it gives you all the possible networks. What happens if you have high levels of noise in your input data and there's actually basically no network which correctly would describe this data? Can you still get basically the closest answer to describing the data?
Yeah, I didn't really have time to go into the details of this, but the thing is that due to this step here, this rectification step, we're actually finding a transitive closure which is closest to the data. So, I mean, what you can also see in the proceedings paper is that I've shown, like, if you have very noisy data, it makes a lot of sense to take out, to define a certain threshold where you say, here, I cannot really decide whether or not something responded, and take out these data points. And then you will increase your solution set, basically. But you will always, since you're rectifying, you will always end up with a transitive closure, and therefore you will always have networks that can describe this transitive closure.
Because you're focusing on transitive closure, is it possible that you'll have a lot of indirect effects in that when there shouldn't be a direct edge between 2 proteins, do you normally see an edge between them just because there's a path that exists between them?
Just because there's what between them?
Just because there is a path between them, does that mean should they be directly connected?
Yeah, so if you don't plug in additional prior knowledge here, you would basically get all the combinations. So you would get the direct path and you would get all the indirect paths. But so this is why it's crucial, if you really want to talk about the details of these networks, then you need to add these prior knowledges, and you need to be able to say, okay, so maybe I have 2 proteins that are in different compartments and therefore they cannot be a direct edge, or I have something like a sparsity constraint, and this way you can sort of filter out these other solutions.
Then I would like to thank Torsten, and we're going to move on to the next speaker.